Continuing in 1-2 with our characteristics of functions, we are now going to go into even and odd functions. And we can see whether a function is even or odd by looking at it graphically, numerically, and or algebraically. Graphically, for an even function, it will be symmetric to the y-axis. So everything on the function that is to the right of the y-axis will be exactly the same as it is off to the left of the y-axis. And so we can see symmetry again. The y-axis perfectly dissects an even function. Numerically, if we look at the x values, you can see that we're increasing from -3, -2, -1. But what we want to pay attention is to the y, so that when x is -3, y is 9. But also when x is 3, y is also 9. And you can see the symmetry through the table. And algebraically, if you take a value, so let's say we take a function and we plug in -3 to that function and we say it is equal to x squared. So we're going to take that -3 and we're going to plug that in for x. And if we square it, you see that -3 squared, any value that is negative that is being squared ends up to be positive. But then if we take that opposite of that value and work it with the same function, plugging it in for x, you also get the same answer, 9 and 9. That is an even function. An odd function, on the other hand, is, we'll go down below here. An odd function is not symmetric to the y-axis. It is symmetric with the origin. It has symmetry with respect to the origin. That is an odd function. We can see that graphically. Numerically, you can see that when x is -3, y will be -27, but when x is +3, x will be the opposite. So odd reflects opposite values in the table. So for instance, we know that x cubed is an odd function, so I'm going to plug in 4 here for x cubed. So I'm going to do the same thing, picking any value that I want for x. Cubing that, I get 64. Whereas if I would plug in a -4 into x cubed, I am looking for the opposite of 64, and I do in fact get a -64. And these two are opposites of one another that we have. Therefore, if we plug in an x value and the opposite of x and simplify into a function, if results are same, you have an even function. If results are opposite, you have an odd function. Now let's look at this middle one. Symmetry with respect to the x-axis is not a function. It does not pass the vertical line test, so therefore it is not a function. So if it's symmetrical to the x-axis, we do not have a function. So it is neither even nor odd. So numerically, you notice that I have, if I plug in 9, I'll get -3, but then if I plug in 9, I get still a different answer. And remember, every x has to have a unique y. And so this 9, if I plug in 9 once and get -3, I better plug in 9 again and still get -3. I do not. Therefore, I do not have a function. And so this is one that is not a function. If results are not the same and they are not opposite, so if the results are neither of the above, then it is not a function. Okay, so our three definitions. So if we plug in a value into a function, and we get an answer. Then we take the opposite of that value and plug it into that exact same function, and we see that results are the same, it's even. If we see the results are opposite, it's odd, and if the results don't match up at all, then it is not a function. It is neither even nor odd. We flip to the back side and we can see some of this, and we're going to first verify even or odd graphically. So we go to our calculator and we're going to type in x squared plus 3, and we will graph it. Again, making sure that our window is set to standard, and we'll probably get a better picture that way. I see that I have a parabola, and what is happening to the right hand side is also happening on the left hand side. It is being dissected. The y-axis is bisecting the parabola, so therefore I have an even function. Now we're going to prove that algebraically down here. So let's just take the number 2, and we're going to take, and that's random, you can choose any number you choose. Taking the number 2, we plug it in for x. So I have 2 squared plus 3. 2 squared is 4. 4 plus 3 is 7. Now, I better get 7 when I plug in negative 2. So negative 2 squared plus 3. Negative 2 squared is 4. 4 plus 3 is 7. 7 equals 7. Therefore, it checks, so therefore I have an even function. The second one, let's type that one in. I get x squared minus 2x minus 2. I'm going to graph that. And I see that I have another parabola. So if you were thinking all parabolas are an even function, well, this might just prove us wrong. Because here's the y-axis, and is the y-axis bisecting this into 2 exactly? It is not, because there's my vertex. This axis would have to be the axis of symmetry in order for that to be an even function, and it is not. So I would say graphically that this is neither. It is not even, it is not odd. It does not reflect over the origin, and it does not reflect over the y-axis. Let's prove it algebraically. So using 2 again, and again you can choose any number that you choose. 4 minus 4 minus 2. That's 0, so that equals negative 2. Now I'm going to take the opposite of 2, and let's see what I get. Negative 2 squared is 4. Negative 2 times 2 is a positive 4, minus 2. 4 plus 4 is 8, minus 2 is 6. Negative 2 does not equal 6, so therefore it is neither. We verified that algebraically. Then our last one, typing in, we have x cubed. Let me clear that out. X cubed divided by quantity 4 minus x squared. Oops, I'm not sure I'm getting trigger happy here. Put that square in there and I'm still not getting it. There we go, sorry about that. 4 minus x squared. I graph that. That's an interesting. I have 3 sections. This would be infinitely discontinuous if we were looking at that. We have a decreasing to an increasing. We have an increasing. We have an increasing to a decreasing, if you wanted to look at all those in terms of increasing and decreasing. But I see this, and I see that I have, here's my origin, and if I would flip that over the x-axis, over the y-axis, and then flip it again over the x, would I end up with the same graph? And I would. So this would be a situation in which it is symmetric to the origin. You could flip it over the x, you could flip it over the y, and you would end up with the same graph. So just by looking at this graphically, I would guess this to be an odd function. Let's look at it algebraically. So let's just pick, since it's a cubic, let's pick 1 instead of 2. I guess you could have still used 2, it doesn't matter. 1 cubed divided by the quantity of 4 minus 1 squared. 1 cubed is 1. 4 minus 1 squared is 3. So I end up with 1/3. But if I plug in -1, -1 cubed divided by 4 minus -1 squared, that's -1 divided by, that becomes a +1. 4 minus 1 is 3, but I get -1/3. So 1/3 is opposite to -1/3. They are opposites of one another, so that does make it an odd function. So even, odd, and I did not do this when we were going through, but it's always a good idea to go to your table and let's look at that. And we can see at -4, I have 5.3, and if I would go to +4, I have a -5.3. 3 results in -5.4, and here I've got a +5.4. -2 and 2 create errors. Those will be vertical asymptotes, and we will see that as we get into our asymptotic unit. So looking at our table on each one of these graphs, you would have also seen that on the table for neither, the table would not have shown up to be the same on the y values, but on even, every time I plugged in 2, I would get a value. -2 would produce that exact same value. -3, a value, and +3, the exact same value. So even, you have the same when plugging in opposites. Odd, you have opposites when plugging in the opposite values. Neither, it comes out to be not even close to what you had before. Even and odd functions.